Hi and welcome to today's session on loci. Now, some of you may not be aware of loci, some of you may be, but when we're talking about loci, what we're just talking about is placement, location. So when we are asked to demonstrate loci, what we're looking to do is create paths or create regions which satisfy our given problem. So when we are doing this, we are going to be using a lot of skills that we use during construction. So constructing lines, angles, shapes. So my first example, here I've got a swing ball. This is an outdoor game where we've got a pole, a rope connected to the pole with a tennis ball on the end. So if I wanted to create a path or region for where the ball travelling, what I'd start off with my point P, which is the top of my pole, looking directly down. I'd measure out 1 meter line, which is the length of my rope, and I'd have my little green ball at the end. Now, if I wanted to show the path of the ball, what I'd do is I'd open up the compass. So my compass point was in point P, my pencil was at the ball, or 1 meter away, and then I'd draw a circle. And this has created the pathway of the ball. Now, first point I want to stress is that anytime that you're asked to make a region or create loci or create a path around a point, it's always going to be a circle. As always with construction, never ever rub out any of these lines because these are your construction lines. These are your method marks. So the key thing that I'll try and pick up on, because people do find it difficult to relate to topics such as this, is trying to relate it to something that they use every day. In which case, Wi-Fi signal is a good one because near enough all my learners, they've got their own router. In which case, the Wi-Fi is in the house. In which case, most ones which you buy from the shops, they've got a 10-meter radius, a 10-meter strength. In which case, from where the Wi-Fi is inside the house, 10 meters away, that would become my radius, and I'd create a circle because there's my center point. And anytime that you're creating a path from a point, it will always create a circle of a 10-meter radius in this case. And what I would shade in this region just on the inside, because everywhere within this region is where I would get signal. Anywhere outside of this, I don't get signal, in which case this region does not satisfy my problem. Everywhere within this circle, I would get Wi-Fi strength. So, key points to remember. Anytime that we're creating loci or path around a point, it's going to be a circle. Now, when we've got a line segment, we've got to remember at the end, either end of that line, we've got a point at the end of either that line. So anytime that we've got a line, we are going to create circles around those points. If we are creating loci against a straight line, we are going to create a parallel line parallel to the line which is given. Bear in mind that if we're asked for the word perpendicular line, that's going to be a right angle line, a 90-degree line from the base. And the word bisecting, that means to slice in half, to cut in half. So here we've got our line segment, line AB. And what we're going to do, we are going to create a 3 centimeter path around this line. Now, normally when I give this problem to students without any teaching beforehand, I normally get maybe line which is 3 centimeters away on either side, and then sometimes triangles on the end of this. Just going to show you exactly what we need to do. So first thing that we're going to do, we're going to open up our compass to 3 centimeters, measuring it using a ruler, and then at point A and point B, we are going to draw circles at the end of our lines, because bear in mind, we've got point A, point B. Anytime that we're creating a path around a point, it's going to be a circle. Now, we are going to think about our line here. We need a 3 centimeter line, which is going to create a path along our line segment. So it's going to be equal distance away from our line segment. With this, it's quite simple. We are going to simply connect the highest points and the lowest points of our circle. Because all the way along here, this has now created a parallel line, which all the way along is 3 centimeters away above and below. Now, around the edge of our created shape, we are going to put this in a bit thicker, so it emphasizes this is our solution. Now, if maybe our problem was that we had to stay within 3 centimeters of our line, we would shade in the region inside of this, because everything inside here is 3 centimeters within 3 centimeters. If we had to be at least 3 centimeters away, we'd shade in the area on the outside of the shape. We could get a problem where we've got to create a path which is equidistant from 2 points. So here's my 2 points, point P and point Q. To begin with this, what I want to do, I want to join up these 2 points. Now I'm going to construct a perpendicular line bisector of this line here. So what I'm going to do, I'm going to put my compass at point P, open up further than halfway, and I'm going to draw an arc. I'm going to keep the compass the exact same, flip it over so the compass point is at point Q, and draw an arc going the other way. Where these two have gone and crossed, these two pairs have crossed, I'm going to draw a line using a ruler going straight away through. Now along this line here, this has created a path which is equidistant from point P and point Q all the way along here. But we could have a problem where maybe the problem is that I've got to be closer to P than Q. If I had a problem like this, I would shade in the region which is to the left of my line, because everything along here is closer to P than it is to Q. Here I've got 2 lines, P and Q, which join up to make an angle, and I want to create a path which is equidistant of P and Q. It's equal distance away from these 2 lines. To do that, I'm going to create an angle bisector. So I'm going to open up my compass and draw an arc which is going to cut both of my lines. Normally I'll keep my compass the exact same, the same length, and I'll put my compass at my point here where it's going to cross and create an arc. Keeping the compass the exact same, I'm going to put my compass point at the other point where my arc is going to cross the line, and I'm going to draw an arc so it crosses my previous arc. Now from here where these 2 lines have gone and crossed, I'm going to draw a line from the vertex of my angle, from the corner, going through where my 2 lines have crossed. Now this has created a path which is equidistant from P and Q. But I could be asked for the region which is closer to P than Q, in which case I'm going to shade in the area which is above this line, because everything here is closer to P, line P, than line Q, because this line is smack bang in the middle of these 2 lines. Now, slightly different problem. Here I've got a quadrilateral, I've got a rectangle, ABC, and I've got to create an area which is 3 centimeters around this point. So to do that, first thing I'm going to do, I'm going to put my compass at point B, so vertex B, measure out 3 centimeters, and I'm going to draw a circle. But I'm going to do this at point B, point A, point D, and point C. So at each of the corners, I'm going to draw a 3 centimeter circle. Now, on each one of these, I've got line segments, and to create a path or a region which is equidistant away from a line, I need to create a parallel line. So I'm going to connect up the highest points of each of my circles, which is going to create my parallel line. Now, by drawing this in a bit darker, this has now created my pathway, which is 3 centimeters away from this rectangle. Now, if my problem was asking to be at least 3 centimeters away, I'll shade in all of the area which is outside of the path which I've gone and created. If you like what you see, please subscribe. Thank you very much for watching.